Good afternoon, everyone. Today I am going to take class about springs. First of all, we have to know about what is a spring and what is the function of the spring. In locomotive, we are mainly using springs as a suspension for suspension purpose. Like in locomotive, a spring is a mechanical compound used in the suspension system to absorb shock, support load, and maintain stable contact between the wheel and the track. Its main function is to shock absorption. While the locomotive is going through the irregular tracks, there will be some vibration. These vibrations are taken by the springs, and it is dissipated by rebounding. Next, load distribution. Another thing is load distribution. It is playing one important role in load distribution of the loco body. Like in P7, we are having two types of springs. They are primary springs and secondary springs. As the name is given according to their function and location, these primary spring and secondary spring are helpful for the load distribution in locomotives. Next, vibration reduction, as I already told. Then ride stability and wheel drive contact maintenance. Next, we are studying why the spring failure is happening. After studying these all by RDSO and several railways, we came in to know that this failure is mainly due to poor manufacturing, lack of inspection. Material met the specs, but the geometry was faulty. Geometry means its thickness, its length, its free height. So many geometries are there for the springs. These all are faulty and not as per the requirement. Main cause, why the crack is happening. Crack is happening due to the when the inactive coil come in contact with the active coil. Come in contact means it's not a normal contact. It should be it must be a some type of pointed contact. When this pointed contact make notches on the active in the active coil, further this notches leads to further this notches leads to fatigue, and lastly it will be leads to the breakage of the spring. This is the top portion of a spring. This portion is called as the inactive coil. This part, these all parts are called as active coil. When the inactive coil, this is the inactive coil. This is a tip part of the inactive coil. When the tip part of the inactive coil come in contact with the active coil, just like pointed contact, there will be some fatigue formation. When fatigue is formed, further it leads to the breakage of the spring. So this first layer is called as the inactive coil. After that, that layer is called as the active coil. As you can see, this is a pointed contact. See, there should be one line of contact that I will explain later, but this is a pointed contact. This is the one type of the problem that leads to the breakage of the spring. Correct spring configuration, how the spring has to be, or how the spring has to be placed, how the spring function to be. First, the tip must be round off, no sharp edges. The tip, I already told you now. This is the tip portion. The tip portion must be sharp and not to be sharp. It should be smooth and round off condition. There should not be any bars or sharp edges for this. For the inactive coil, when any sharp edges are found here, it may lead to the breakage of the spring. Then main point is contact must be line of contact over 1 by 3 of the dia of the spring. What is line of contact? In the earlier style, I told you that this is a pointed contact. Line of contact means from here to here, contact should be there. I think everybody is getting. From here to here, there should be a line of contact. This is a pointed contact from here to here. The length is 48 mm. There should be minimum line of contact of 48 mm of the mean dia of the coil. What is the mean dia? Mean dia means from this center portion to this center portion. This length is called as the mean dia. 1 by 3rd of the mean dia should be there for the line of contact. Then No biting under load or no load condition. Biting means the same thing. There should not be any pointed contact. That's the same thing is they are using the word biting under load and no load condition. Next, spring end phase requirement. End phase means this is also called as a end phase. End phase means this is a place we are placing on the on the plate or where the spring has to be. This place must be very smooth. There should not be any bars or any kind of sharp edges. Okay. Also, this is the first point. Requirement of for the spring end phase. Both the end phase of the spring must be grounded to ensure square seating. Square seating means this is a place we are going to place. Okay, so this should be uh, this should be should place in that portion firmly. There should not be any gap. That is called as square seating. Square seating means perfectly seating. There should not be any bars or any gap between the place where we are placing and the end face. End must be free from sharp edges and bars and should be round off. Next is the main point. The actual ground end surface shall be at least 75 percentage of the mean coil circumference of the spring. Because this is the one round. Okay, it's 75 percentage should touch the ground or should touch the place where the spring has to be seated. End face must not show blow marks from grinding, as these may lead to timber brittleness, which means uh, a process guard grinding is used for this getting this finishing. Okay, while doing grinding, maybe they will give some extra pressure, or otherwise they will not use some proper kind of liquid for cooling it. That may lead to the lead hotspot in the material. That hotspot damage the material strength and all, further leads to the crack. Next, tip thickness requirement. How has to be the spring thickness? Spring thickness. There are two conditions. One is if the bar dia is above 33 mm. This is a bar dia. Okay. If the bar dia is above 33 mm, the thickness of the tip should be 1 by 5th of the bar dia. If the bar dia is below 33 mm, the thickness of the tip should be 1 by 4th of its nominal bar dia. Spring coil pitch. Coil pitch means this is a one circle. This is another circle. The between this one gap is there na. That is called as the pitch. Pitch should be uniform. Okay, from the for the whole spring the pitch should be uniform. There should be uneven pitch, uneven pitch. We will most of the time while testing, if we are getting uneven pitch, we will reject the spring. I think it's a coil pitch shall be sufficiently uniform to ensure proper spring performance. Then next, while spring is compressed to a height of representing 85 percentage of the nominal total travel, no coils shall contact each other excluding the inactive end coil. Which means we are doing load test for the springs. While applying the load, load means if suppose it is 4 ton, we are giving 85 percentage of 4 ton. Okay, while giving 85 percentage of the load, the the pitch must be uniform. There should not be touch between the active coil. Touch can only occur in the only one portion is allowed for the touch, that is line of contact between the tip portion of the inactive coil and the active coil. That is the tender excluding the inactive end coil. Contact between the inactive coil and adjacent effective coil, when it occurs, shall happen over a minimum length of 1 by 3rd of the mean coil diameter of the spring. This point is I already explained. Next, inspection checklist. What are the things we have to check while doing spring testing or during inspection? First point is rounded tip, no sharp edges. And second point, end grinding is okay. No, end grinding should be okay. No bursts or burns. Proper tip gap. Line of contact should be greater than 48 mm. Coil pitch to be checked. Conclusion. For avoiding this type of failure, we must follow SMI whatever railway is providing. Always follow RDSO specification. Thank you.